Welcome to the DIY Honda Garage channel. The error code, DTC P2183, indicates an issue with the ECT sensor 2, which is related to its circuit range or performance. The engine coolant temperature, ECT sensor, is responsible for monitoring the temperature of the engine coolant, which is essential for the engine control unit, ECU, to optimize fuel flow and engine performance. In Honda vehicles, the ECT sensor 2 is typically located on the engine block or cylinder head, usually near the radiator. The readings from this sensor can influence various engine parameters, including fuel mixture and ignition timing. The occurrence of DTC P2183 suggests that the ECT sensor 2 may not be providing accurate readings as expected, which can lead to suboptimal engine performance and increased emissions. It's crucial to address this issue promptly to maintain vehicle reliability and efficiency. The ECT sensor 2 plays a vital role in monitoring the temperature of the engine coolant. It sends data to the engine control module, ECM, which adjusts fueling and ignition timing to ensure optimal engine performance. Typically located near the engine block, this sensor provides critical information about how hot or cold the engine is operating. If the sensor fails or provides erroneous readings, it can lead to inefficient engine operation and might cause the check engine light to illuminate. The presence of DTC P2183 also indicates that the thermal range or performance characteristics of this sensor fall outside expected parameters, which needs to be rectified to prevent further engine-related issues. Several factors could lead to the activation of DTC P2183. The first possibility is poor connections, which could involve loose or corroded terminals at the ECT sensor 2 or ECT sensor 1, leading to unreliable signal transmission. Another common cause is a faulty ECT sensor, which may fail to produce the correct voltage output as the engine temperature changes. Additionally, the wiring harness associated with the ECT sensor may be damaged or shorted, affecting the sensor's ability to relay accurate information to the ECU. Each of these potential issues can cause the ECM to trigger DTC P2183, as it identifies an inconsistency in expected performance values. When DTC P2183 is triggered, several symptoms may manifest noticeable issues. The most immediate indicator is the illumination of the check engine light on the dashboard. This occurs as the ECU detects that the ECT sensor 2 is underperforming. Additionally, drivers may notice engine performance issues such as poor acceleration, rough idling, or decreased fuel efficiency, which all stem from ineffective temperature regulation. Increased emissions may also occur as the engine fails to operate within optimal temperature ranges, leading to unburnt fuel and harmful pollutants being expelled into the atmosphere. It's essential to pay attention to these symptoms. They serve as important cues suggesting underlying problems that require immediate troubleshooting. The first troubleshooting step for DTC P2183 involves a visual check of the connectors associated with the ECT sensors. Technicians should thoroughly inspect both ECT sensor 1 and ECT sensor 2 for any signs of poor connections or loose terminals. Connectivity issues can lead to faulty readings or intermittent failures, resulting in the activation of the code. Ensuring that all connections are clean and secure is critical to the effective functioning of the sensors. If the connections appear to be in good condition, the technician should then proceed to the next troubleshooting steps to continue diagnosing the fault. If poor conditions are found, they must be repaired before further steps are performed. In the second step, the technician should turn the vehicle's ignition to the on position without starting it. Using a diagnostic tool like HDS, Honda Diagnostic System, Check for any confirmed or pending DTCs. It's crucial to ascertain whether DTC P2183, which involves ECT sensor 1, is stored alongside DTC P2183. If both codes are present, troubleshooting for DTC P0118 should take precedence, as it could potentially complicate the diagnosis of P2183. A careful review of DTCs can provide insight into multiple sensor-related issues, helping to streamline the repair process. If no simultaneous codes are found, the technician should proceed to the next troubleshooting step for P2183. During this troubleshooting step, the technician needs to start the engine and allow it to idle for a duration of 10 minutes. After this period, they should consult the HDS to monitor specific parameters related to ECT sensor 2. It's essential to evaluate the current condition against the established threshold values, which dictate that ECT sensor 2 should register less than 120 degrees Fahrenheit or 49 degrees Celsius. If the sensor's output aligns with these thresholds, it may indicate that the sensor is in good working condition, while discrepancies suggest a failure. Should the sensor readings exceed the established criteria, it is recommended to replace ECT sensor 2. Recognizing the performance characteristics of the sensor is fundamental to diagnosing the legitimacy of the error. For this step, the vehicle must be turned off to allow ECT sensor 2 to cool down to the ambient temperature. After ensuring the engine has cooled sufficiently, the technician should record the ambient temperature. Once the vehicle is turned back on, they should quickly check the value for ECT sensor 2 using the HDS data list. The critical point here is to evaluate whether the ECT sensor 2 reading differs from the ambient temperature by more than 5.4 degrees Fahrenheit or 3 degrees Celsius. If such a difference is observed, it substantiates the malfunction, and the technician should proceed with replacing ECT sensor 2. Alternatively, a smaller deviation may indicate an intermittent fault, prompting a check for poor connections or loose terminals at both ECT sensors and the powertrain control module, PCM. In this step, the technician must ensure the engine is running and left to idle for approximately 10 minutes. After this idling period, it's important to monitor the parameters of ECT sensor 1 via the HDS system. Similar to previous readings, the conditions for ECT sensor 1 should also register less than 120 degrees Fahrenheit or 49 degrees Celsius. If the values match the expected thresholds, it indicates that ECT sensor 1 is functioning correctly, allowing the technician to move on to step 6. Conversely, if the temperature exceeds these parameters, ECT sensor 1 should be replaced to resolve the issue at hand, as a malfunctioning sensor can contribute to inaccurate engine temperature readings, affecting overall vehicle performance. The sixth step mirrors the previous performance checks, but focuses again on ECT sensor 2. The engine should be allowed to idle for an additional 10 minutes to ensure accurate readings are obtained. Subsequently, the HDS should be utilized to evaluate the parameters of ECT sensor 2 once more. The expected conditions for ECT sensor 2 remain consistent, with values needing to be less than 120 degrees Fahrenheit or 49 degrees Celsius. Should the reading confirm this threshold, it would indicate the sensor is still functioning within acceptable limits. However, if the threshold is not met, the technician should proceed with replacing ECT sensor 2. Proper checks at this juncture are essential to ensure any faulty component is identified and dealt with, safeguarding engine performance. For the final troubleshooting step, the technician will repeat the process of turning the vehicle off, allowing the sensors to cool down to ambient temperature. After this cooling period, the ambient temperature must be recorded once more. The technician then needs to power the vehicle back on and simultaneously check the values of both ECT sensor 1 and ECT sensor 2 using the HDS. It's vital to compare the readings of each ECT sensor against the previously noted ambient temperature. If either sensor shows a difference of more than 5.4 degrees Fahrenheit or 3 degrees Celsius from ambient, it indicates a fault and the affected sensor should be replaced. If both sensors are within acceptable limits, it suggests an intermittent issue. Thus, a thorough check for poor connections or loose terminals should be conducted at ECT sensor 1, ECT sensor 2, and the powertrain control module, PCM, as a follow-up action. Once repairs have been made, it's crucial to verify that the issues associated with DTC P2183 have been adequately addressed. The first step involves confirming the successful replacement of any faulty sensors. After ensuring the replacement was effective, the technician should check for any stored DTCs using the HDS. If no new codes appear, it may signal successful repairs. Finally, a test drive should be performed to ensure that the vehicle operates under normal conditions while monitoring for any anomalies that may still suggest an underlying issue. This step ensures the problem is indeed resolved and that the vehicle is functioning as intended. Preventive maintenance is essential to avoid future occurrences of DTC P2183. Regular inspections of the wiring and connectors linked to the ECT sensors can help identify wear and tear that might lead to connectivity issues. Ensuring that connections remain clean and corrosion-free is vital for accurate sensor performance. Additionally, monitoring coolant levels regularly and ensuring that the cooling system is functioning efficiently is fundamental to the overall health of the engine. Keeping a close eye on these aspects will not only enhance vehicle performance, but also prolong the life of critical engine components, ultimately leading to a more reliable and efficient driving experience. In conclusion, DTC P2183 signifies potential issues with the ECT sensor 2, which can significantly affect engine performance if not addressed. A systematic approach to troubleshooting, as outlined in the previous slides, is crucial for accurately diagnosing the problem and determining the necessary repairs. By carefully checking connections, monitoring sensor output, and comparing values to ambient temperatures, technicians can effectively identify faulty components needing attention. The importance of preventive practices, such as regular inspection and maintenance, cannot be overstated, as they help ensure reliable vehicle operation and extend the life of various engine components. Taking the time to follow these protocols will lead to a more efficient and trouble-free driving experience. Please like and subscribe to the channel. See you next time.